Hello everyone, in this video I'm going to be solving for the integral of x times square root of 1 minus x to the power 4 dx. First, we're going to use U substitution. If we set u is equal to x to the power of 2, then that would give the du as 2 times x dx. Divide 2 on both sides and we'll get 1/2 times du is equal to x times dx. We don't have to worry about the x and a dx anymore because we can just replace it with 1/2 times du. And 1/2 can go in the front since it's a constant. And we'll just have 1/2 times the integral of square root of 1 minus the x squared is equal to u. So we'll just have u squared. And to integral this, we're going to have to use trigonometric substitution. If we set u is equal to sine theta, that would give us du as cosine theta times d theta. And replace the u with sine theta, and you'll get this. Also replace the du with cosine theta times d theta. This is a trigonometric identity, and note that 1 minus sine squared theta is equal to cosine squared theta. But since we have the square root, we'll have just cosine theta. That would give us 1/2 times the integral of cosine theta times cosine theta d theta. We can multiply these together to get cosine squared theta d theta. To solve for the integral of cosine squared theta, we'll have to use cosine 2 theta, which is equal to 2 times cosine squared theta minus 1. Solve for cosine squared theta, and you'll have 1/2 times cosine 2 theta plus 1. We're going to replace cosine squared theta with what we got here, and we'll get 1/2 times 1/2 can also this 1/2 can also go in the front of the integral since it's a constant, and multiply these two with the integral of cosine 2 theta plus 1, and this is just 1/4. The integral of cosine 2 theta is equal to 1/2 times sine 2 theta, and the integral of 1 is just theta, plus c. We can simplify this more by multiplying it out, which then we would get 1/8 times sine 2 theta plus theta over 4, and plus c. This is not our final answer yet, because when we started, we had the variables in terms of x, but in the end we had it in terms of theta, so we're going to have to change it so that we would have x as the variable again. I'm going to try to change the sine 2 theta in terms of x first. So we know that u is equal to sine theta from here, and using this we can create a right triangle. If we say that this angle here is equal to theta, then since sine theta is equal to the opposite over the hypotenuse, this is equal to u over 1, so the opposite is u here, and the hypotenuse, the length is 1. Using Pythagorean theorem, we'll have square root of 1 minus u squared as the length of the adjacent. And we know that sine 2 theta is equal to 2 times sine theta times cosine theta. And also, we can replace the sine theta with u. We already know that. So 2 times u times cosine theta, which is equal, well, cosine theta is equal to the adjacent over the hypotenuse. So that would be a square root of 1 minus u squared over 1. So we'll just replace the cosine theta with what we have here. Square root of 1 minus u squared. And so now we have to replace the u with x squared, because u is equal to x squared. So we'll just have 2 times x squared times square root of 1 minus x to the power 4. We finally we changed the sine to theta in terms of x. But now I'm going to focus on changing theta in terms of x. So theta, we're going to try to change it in terms of x. We know that u is equal to sine theta. And if we solve for theta, then we'll have theta is equal to arc sine u, and u is equal to x squared, so that would give us arc sine of x squared. So we can replace the theta here with arc sine of x squared. I'm going to erase here since we don't have enough space to write our final answer. So what we last had was this. So 1/8 stays, times sine 2 theta is equal to this, 2 times x squared times square root of 1 minus x to the power 4. And the theta is equal to arc sine of x to the power of 2 over 4, and lastly plus c. We can simplify this a little bit more, like in the front. We'll have 1/4 times x to the power of 2 times square root of 1 minus x to the power of 4 plus arc sine of x squared divided by 4 and plus c. This is our final answer for the integral of x times square root of 1 minus x to the power 4 dx. Thank you so much for watching this video, everyone, and have a great day.